For 5-7, we're actually not going to do any homework over this one. This is just some good things to know about polynomials in general. So the first thing is, just like when we had quadratics, there are really 4 different ways to say, to talk about the same thing. Okay, so first of all, you have zeros, roots, factors, and X-intercepts are all kind of the same thing. Okay, so remember, when you factor out a polynomial, you get something like this, an x minus c. That means that c is a root, 0, and an x-intercept of the polynomial. Okay, so just like quadratics, same thing here. You should already know that. Okay, the next thing is we have this is called the fundamental theorem of algebra. And again, these are all very, very mathematical definitions and stuff like that. So good for you to read them, good for you to know them, but maybe not super duper helpful. Okay, the first one is that every polynomial equation with a degree greater than 0 has at least one root in the set of complex numbers. Okay, so at least one. You have a root if you have a degree greater than 0. So even a linear equation has a root, right? Because it has an x-intercept. Okay, at least one. And it says at least one root. It doesn't say at least one real root. So even though we have quadratics that never cross the x-axis, they still have imaginary roots. So at least one root. The corollary to this is that whatever the degree is, you're going to have at least that many roots. Okay, so if you have a linear graph, you're going to have at least one root. If you have a quadratic graph, you're going to have at least 2. If you have a cubic, you're going to have at least 3. You're going to have 3 roots. They could be imaginary, but you're going to have 3 roots. Okay, a 4th power, 4 roots. A 5th power, 5 roots. That is your fundamental theorem of algebra. Okay, whatever the degree is, you're going to have the same number of roots. This rule of signs is a big one that I really kind of only find interesting. I never use this, but it is kind of nice to know. So what it actually says is, if you have a polynomial and it's arranged from highest degree to lowest, so an x cubed, x squared, x number, okay, then the number of positive zeros, positive real zeros, is going to be the same as the number of times the sign changes. So for example, looking at this question right here, this is looking at this, how many times does the sign change just of the coefficient? Okay, so it changes from a positive to a negative, that's 1. Stays negative, changes positive, that's 2. Okay, changes back to negative, that's 3 different sign changes. So this is a degree of 4, right? I had 3 sign changes. That means that there's at least 3, or there's 1 positive real zeros. Okay, positive real zeros. So this is kind of the dumb thing, because it's if you get 3 sign changes, it's either 3 or 1. So that's kind of, if you had 5 sign changes, it would be 5, 3, or 1. So that's why I don't really find it that helpful, but it is kind of interesting. And the same thing, if you plug a negative x in there, so that's what they did down here. They plugged in the negative x and got the new polynomial. Well, how many sign changes here? Positive number, positive number, positive number, changes to a negative, so that's 1, stays negative. So that means there's only 1 negative real zero. Okay, so like I said, kind of interesting, maybe not super duper helpful. The last one is your complex conjugate theorem, and we've actually dealt with this before. If you have an imaginary root that looks like this, then the other one is also going to be a 0. So just changing the sign. Remember, those are your complex conjugates. Okay, so like I said, just some math vocabulary stuff here, no real work. Be sure you watch the next video.